All right, in this video, we want to solve this calculus optimization word problem over here where the volume of a square-based rectangular box is 1000 centimeters cubed. And we need to find the dimensions that minimize the surface area. And it says that each dimension can have a minimum length of 2 centimeters. So let's just start by drawing out a square-based rectangular box. Doesn't have to be super accurate, the diagram. Just want to try and get it as good as possible. So the bottom is square based, so I can label that as X and X because it's a square, so they're going to have same side lengths. And then I'm just going to label the height as H. So I know that the volume of this figure has to be 1000 centimeters cubed. So I know my volume equation is just length times width times height for any rectangular prism. And then I know that the volume in the question is given as 1000. Length and width are both x. So x times x is x squared. And then the height is just h over there. Now I need to come up with a second equation for my surface area. So the surface area of this entire figure, so area of the bottom is just x times x, which is x squared. And then I'm going to multiply that by 2 for the top and the bottom. So it's just going to be 2x squared. That's the top and the bottom. And then the area of this front over here is just x times h. The area of the back is also x times h. The area of the right side is also x times h. And then the left side is also x times h. So that's just 4xh. And since this is just an area question, it's not a cost question, I can just write out this equation instantly. If it was a cost equation, I would have to write out each side separately and then multiply the cost of each side with whatever that side area was. But since this is just a minimizing an area question, I can just combine them instantly over here. So I need to minimize the area in this question, which means I have to derive it. But the problem is I have two variables here, so I have to get rid of one of the variables. The easiest variable to get rid of is the h. I'm going to get rid of the h over here by just dividing by x squared. And then I'm going to sub that in over here. That's just 1000 over x squared. And now I just have to simplify this a bit. I can cancel this x with the square. And then I can rewrite this as 2x squared plus 4000. And instead of writing over x, I'm going to move the x to the top in the same step. I'm going to make it x to the -1 because I know I have to derive this in my next step. So may as well do that all in one step. Now I can derive this equation. So a prime is just 4x minus 4000 x to the -2. Then I just need to make this equal to 0 and solve to find my critical point. So I'm going to make this equal to 0. And over here, I'm going to move the negative exponent to the bottom so that it's easier to solve. I'm going to move this entire term to this side and make it positive. I'll cross multiply the x squared. Oops, x cubed. Divide by 4. And then I'll cube root the other side to get rid of the cube. So cube root of 1000 is just 10 equals x. So this is my critical point over here. Most probably this is the value of x that minimizes the solution, but we have to test the endpoints. We have to test this point as well to make sure that this actually minimizes the areas. So how do we find the endpoints or the domain of this question over here? Well, the question says each dimension can have a minimum length of 2 centimeters. So the minimum value of x over here is 2, and this x is also 2. So my domain is basically my x minimum value for x. I'll actually write it over here. My minimum value for x is 2. But what is my maximum value of x going to be? Well, let's say the minimum height is also 2 centimeters, right? So I'm going to plug in 2 centimeters over here in my volume equation. I'm going to solve for x. So 1000 equals x squared times 2. Just going to divide both sides by 2. 1000 divided by 2 is 500. Then I'm just going to square root this. You don't have to worry about the negative solution because we don't have negatives in this type of question. So my maximum value of x is square root 500. You can simplify that if you want. I know that can be simplified, but I'm not really going to bother simplifying it right now. But if you had to, it would be 10 root 5, basically, if you did simplify that square root. So that's my domain in the question. And this is my critical point. And I know that 10 is between 2 and square root 500. So this critical point is valid. So now I just have to test my endpoints and my critical point to see which one gives me the minimum. So all of these I'm going to sub into my area equation. So a of 2, a of 10, and a of square root 500. I'll actually write all my answers here in decimals so I can compare them. And I'm subbing them into this area equation right over here. So let's start with the first one. I'm going to sub in 2 into that equation. So 2 times 2 squared plus 4,000. So that's an area of 2008 centimeters cubed. I'll sub in 10 next. I get 600 centimeters cubed, and I'll sub in root 500 next. One's going to probably give me a decimal answer. I get 1178.9. So if we compare the three areas here, we can tell automatically that when x is 10 centimeters, the area is minimized to 600 centimeters cubed. So I know that x should be 10 for this question. And then after that, I'm going to find the height by subbing in x as 10. Do that over here. So h equals 1000 over 10 squared, which is just 1000 over 100, which is 10. So I know that in order to minimize the surface area of this rectangular prism over here, the square-based one, we have to have the length is 10 centimeters. The width is also 10 centimeters because it's square-based. And then the height I just calculated here is also going to be 10 centimeters. So this box is going to be 10 by 10 by 10. And that's going to give me a min area of 600 centimeters cubed. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.